Good morning, Year 6. It is Tuesday the 14th of July and today we're looking at area of a triangle. So first anchor question. So each square equals 1 centimetre squared. Match each triangle to its area. So knowing that knowledge, we can just go through. So here 1, 2 whole squares. Then we're going to start to match, okay? So I can see that here, this shape, if I was to flip it round, would make this a whole square, that's 3, and then this small part here would fit into this gap here, okay? So I can see that that would be A, 4 centimetres squared. Then next B, again, count the whole squares, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, then 2 half squares here, make it 7, 2 half squares here, make it 8. And then we can check the final one here. So whole squares, we've only got 1, 2. Okay, here 3, 4, 5, 6. So this is C. Have a look at the next question. Seth has estimated the area of these triangles by counting the squares. 1 square equals 1 centimetre squared. Do you agree with his estimations? Explain why. Let's have a look. So he reckons A is around about 12 centimetres squared. Let's have a look. So again, we use the same principle. We count the whole squares. 1, 2, 3 whole squares. And then we've got here, that little bit would fit there to make 4. Half and half, 5. I wouldn't say that is correct. No. So I'd say that is around 5 centimetres squared. Next one, count the whole squares again. 1, 2, 3. Then here, that part and that part would make that 4, 5, 6 centimetres squared. And again, the last one, 1, 2 whole squares, 3, and if anything, 4. So what has Seth done? What is his mistake? Well, he has counted these as whole squares. So let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I think he's counted it as a rectangle as such, or if a part is on a square, he has counted it. Let's see this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's almost like he's counting a rectangle. 8. 1, 2, 3, 4, 5, 6, 7. Yeah, he's counted a rectangle. So we're going to have a look at the video today that will help you with your learning.
Hello there and welcome back. Today we're going to have a look at finding the area of triangles. But we're going to start off with a bit of a review. So we've got 2 rectangles here. Can you find the area of them? So pause the video, have a go at that first. So if we remember from the last time, area is the space inside. So if we can visualise, well, we can see that this is 3 centimetres, and we can see that it is 6 centimetres is its length. So in total, I could work that out by thinking, well, I can see in each row there are 3 centimetres, and I could do that 6 times. Or in each column, I can see that there is 6 centimetres, and I could times it by 3. But that would give us 18 centimetres squared. Right, the one on the right? Well, we can see we've got length is 8 metres, the width is 2 metres, so it would be 16 metres squared. Right then, here's a triangle. We're going to use squared paper to help us first. So, your turn now. How could we find the area of the triangle? And is there more than one way of doing it? Pause the video, think for yourself first. Let's consider method 1. Method 1, which you may have used, may have been to count the squares. So maybe you went, well, I'm looking to see how many whole squares I could get in there. And I can see that there's 6 whole squares. And you may have noticed that I've got some half squares. I've got 1, 2, 3, 4 half squares. 4 half squares is the same as 2 full squares. So in total, I've got 8 squares. So the area of the triangle is 8 squares. So we've got method 1. What about another way? Let's look at method 2. Maybe this is the way you've done it. I like to call it cut it up. So we can visualise cutting the triangle into 2 parts. Let's visualise if I can think about moving the part I've just cut, and I can make a rectangle. Now I know how to find the area of a rectangle. It's just length times width. So I can see this rectangle, which has the same area as the triangle, has an area of 8 squares. So we've got 2 methods in the bag. What about a third one? I like to call it make a rectangle. So can we see, if we make a rectangle, in this case a special type of rectangle called a square, around the triangle, we can find out the area of the rectangle by thinking length times width, which is 4 times 4, or 16 squares. And I can think of the relationship between the area of that triangle and the area of the rectangle. I can see the area of the triangle is half of the area of the rectangle. So to calculate, I could do 16 divided by 2, which gives me 8 squares as well. So, one for you to think about now. You've got 3 different ways of doing it, or maybe there's another way you can think about. Pause the video. Can you find out the area of the triangle? Which method did you choose? Did you come up with a new one? Let's have a look at method 2, see how that would work. Well, I chop it here. I can visualise making the rectangle. In this case, a square. And the area would be 9 squares. Perhaps you chose method 3. Here's our rectangle. The area of the rectangle is 6 times 3, which is 18 squares. And the triangle is half of that, which is 9 squares. So, we haven't got squared paper this time, but can you find the area of the rectangle using the dimensions given? Pause the video, have a go for yourself first. So, we're going to have a look at using the rectangle. Let's complete our rectangle. The area of it would be 10 centimetres squared. But we only want half of that because the area of the triangle is half of the area of the rectangle, so it is 5 centimetres squared. So, 2 for you to have a go at now. Can you find the area of the triangles? Let's have a look at the first one. Again, visualising the rectangle. The rectangle's area is 18 centimetres squared, so the triangle's area is 9 centimetres squared. Again, all on the right, the rectangle's area is 28 centimetres squared, and the triangle's area is half of that, which is 14 centimetres squared. We've got a triangle this time, but it looks a little bit different. In fact, this time we've got a scalene triangle. So, can you think of a way to find the area of the triangle? Pause the video, have a go for yourself. Let's have a think about a way of doing this. What if I divided the triangle into 2 smaller triangles? I could find out the area of the rectangle and then find out half of that to work out the triangle on the left, which is the one in blue. And then I could also draw another rectangle and half that to find the area of the green triangle. Let's calculate. Let's find the area of the blue triangle. Well, that would be 2 times 5 because it's length times width. I divide it by 2, and the area of the blue triangle is 5 squares. What about the green? Well, I would do 1 times 5 because it's length times width of a rectangle, divided by 2, which is 2.5 squares. So what about the area of the whole triangle? Well, I would add 5 squares and 2.5 squares, and the area of the triangle is 7.5 squares. Now, there's another way you can think about this. The area of a triangle is the base multiplied by the perpendicular height. The perpendicular height means at a right angle to the base. And I draw that line until it reaches the top, or the height of the triangle. And then whatever that is, I divide it by 2. So for this triangle, the base, which is the one I've marked in red, in this case is 3. The perpendicular height, so we're going at a right angle from the base until it reaches the height of the triangle, in this case is 5. So my formula is 3 times 5 divided by 2, which we know is 7.5 squares. So I've got a triangle here, and I've got 3 different measurements, and they're all labelled different colour arrows. So which arrow is the base? Which arrow is the perpendicular height? Think for yourself first. Which of those arrows is the base? Which is the perpendicular height? So then, what about the base? Well, could this be the base, the green line? Well, if that was the case, the line in purple would be the perpendicular height. So I could have had that the base, but none of the other lines show me the perpendicular height. What about the red arrow? Well, if that's our base, and we were to draw a 90-degree angle and then draw a line perpendicular to that, it would be the one in blue. So in this case, the blue arrow represents the perpendicular height. So then, using the formula of base times perpendicular height divided by 2 gives me the area of a triangle. Can you find the area of these 2 triangles? Pause the video, have a go for yourself. So, in this case, the 4 centimetres of this bottom line is the base. This is the perpendicular height, 3 centimetres. So my calculation would be 4 times 3, which is 12, divided by 2, which is 6 centimetres squared. The one on the right is quite tricky. In this case, the 8 centimetres is the base, and 4 centimetres is the perpendicular height. It's at a 90-degree angle to the base, and it goes to the height of the triangle. So my calculation would be 8 times 4 divided by 2, which is 16 centimetres squared. Your turn now. Have a go at the worksheet if you have it, but don't worry if you don't. There's material available on the BBC Bite Size website.
Okay, so have a go at the worksheet that has been emailed to you. It should look like this. But also don't forget to have a go at your learning by questions.